Okay, welcome everyone to today's installment of the Region 10 Transportation Conference of 2021 Webinar Week. Today is our fourth installment and our last installment. If you haven't had a chance to join us for the conference so far, it's been going on for about a week now. If you go to PacTransconference.com, you can find recordings of the last 3 days webinar week installments, as well as the opening session that took place last week, Friday. Got a lot of great content there. There's also a tab for a virtual poster session. We have about 20 short videos highlighting a lot of work that has been funded by our UTCs. And then we also have a tab kind of highlighting a few annual awards that PacTrans gives out. Thanks for joining us today. Today's webinar is titled Improving Safety on Roads and Trails in Rural Areas Using the Right Technologies. The last thing I will mention briefly is today at the bottom of your screen, you'll find two icons. One is a chat icon and one is the Q&A icon. As you have questions today, please feel free to put those in the Q&A panel. And as you see questions in the Q&A panel that you are also interested in knowing the answers to, please feel free to click the thumbs up and upvote those questions. And then if you have any issues or other things, you can also communicate with myself or other panelists by using the chat feature. With that, I'm going to introduce today's session organizer and moderator. Billy Conner is the director of the Arctic Infrastructure Development Center at the University of Alaska Fairbanks. And with that, I'm going to turn it over to Billy.
Hey, thank you, Cole. And I hope all of you had a great week at the PacTrans conference and the webinars that we've had. I listened into many of them and found them all fascinating. And hopefully today you'll be just as intrigued as to what we're talking about. One of the issues that people who are living in remote areas, and some areas more remote than others, as we'll see, you'll find that the availability of technologies is much more limited than we have in the urban areas, and that the skill sets and the funding to take advantage of those technologies is much more difficult for them. So the focus of the day is looking at some of those and looking at some of the technologies that they have and how those might be adapted to those rural areas. We'll start out with Jeff Ban and Daniel Abramson. Jeff is a professor at the Department of Civil Engineering at University of Washington. His areas of interest are in transportation network modeling simulation, particularly in connected and automated vehicles, drones, new mobility services, those sorts of things. If you want to know more about him, take a look at the bios that are presented in the agenda. Daniel is associate professor in urban design and planning at the University of Washington and an adjunct in the Departments of Architecture, Landscape, and a member of the China Studies and Canadian Studies faculty. His primary interest is in urban planning and those sorts of things, and community engaged planning, research, and design. So with that, Jeff, I'm going to turn it over to you and take it away.
Thank you, Billy. Good morning, everyone. We're glad to, let me share the slides first. Let me put it on the full screen. All right. Really happy to talk about this drones for the RTI communities together with my colleague Dan Abramson here. So this is a project we've been working for the last couple of years and funded by CSET. And also, in addition to Dan and myself, we have students, Izan, Sarah, and Christina, who did most of the work, and I just wanted to acknowledge their contribution. So we'll talk about why we started this project last couple of years in this RTI stands for Rural, Isolated, Tribal, and Indigenous Communities. And why drones might be a good tool to help them to solve various issues. And we'll talk about the research approach, including outreach activities, online survey, and we conducted a pilot study, and we're in the pilot program phase. And then we'll talk more about this, and we'll also conclude with some brief remarks. So regarding RTI communities, essentially, as probably similar to other communities, they're facing safety and also the so-called emergency preparedness and resilience communities, but issues. But they also have their unique features on this and unique challenges. If you look at the traffic safety, which is one of the focuses of this project, you can see that in generally, if you talk about crashes or fatal crashes, especially the RTR communities has a unproportionately higher rate compared with the rest of the communities. And so this is particularly so for the Washington state, which what we focus on here. Sorry. So not only the traffic safety, the communities, especially the communities we work with in the Pacific coastal areas, they have this sea level rise and also earthquake challenges, and the left figure shows if sea level continue rising and some of the land will be underwater, right? That's some issues community need to address on a daily basis. And if earthquake happens, then a larger piece of the land will be under the water and have huge issues in that regard. So they have to deal with this and come up with solutions to address these kind of challenges. So on the other hand, if you talk about communities, and they oftentimes those communities is sort of classified as no growth communities because they have low population and low growth maybe, and then they don't do very well a long-term planning or growth planning on this. And this means the resources and others are less so to those communities. And also, if you talk about new technologies, and oftentimes they mainly focus on the urban areas, and those communities are largely and for a long time ignored or less, focused. That's sort of our motivation to say, how we could use some of the new technology to help RTR communities to address those safety and emergency or the resilience challenges. And one of those is the drones. Everyone knows drones can help you do a lot of things, including infrastructure monitoring, data collection, search and rescue, and things like that. But different from other, if you talk about connected vehicles, you talk about, the new mobility like Ubers and Lyft, drones might have in the RTR communities may have an edge, which means they might be advantageous to apply to these communities because there are fewer high-rise buildings. It might help them to develop more context-sensitive solutions to the communities, because when you try to solve issues in the communities, we have to make sure the solutions fit into the local culture and what they do there, right? So that's sort of the another motivation for this work. Regarding the drones, this is a very quick overview or about things. It varies. The key message is varies in terms of the technology, power, the sensing technologies, the positioning technologies. It's some are big, some are small, some can carry a lot of weight, others cannot, right? So data collection and the sensing technology are very different. So it varies. So you have to pick up technology that fit your needs or your application that you're targeting on. So the goal of what we do, as I sort of alluded earlier, is try to say, how can we outreach to the community and understand some of their challenges in terms of traffic safety, emergency, and preparedness, and how we can help them to develop solutions, and what are the challenges to develop or adopt those technology-based solutions, drones in particular, right? So the area we started to collaborate is in the outer Pacific coast areas in Washington State, especially the city of Westport, as you can see from some of the partners in this area. So initially we have a lot of ideas, right? So as you can see, drones have been widely used in the urban areas, for all sorts of things, either emergency conditions or even daily usage, right? So many things can be used, and even for data collection. So with that, we started to, communicate and reach out to the communities. The reason we choose Westport is that it's a very typical RTI community, and it's relatively easy access to us. And if you look at this, is sort of so the where Westport located. If you've never been there, it's this is a kind of a bird view of the city. It's a relatively small population, and has more of the challenges that we have indicated earlier. Sea level rise, coastal erosion, tsunami, if earthquake happens, could be a big deal for the local community. And also the transportation infrastructure has been, similar to many other areas in the U.S., has been having some issues for a long time and need to be repaired. This could be even a bigger issue if emergency happens, right? So, but the city did build the so-called vertical structure for evacuation purposes. Like if something happens, the population or residents in the area can sort of move to this vertical structural building to sort of for rescue and shelter purposes. And the approach we started for this project include outreach activities, like we set up studio to students and research and communication with local leaders and residents, and we have multiple meetings, workshops, and online meetings. And after that, we did the online survey, sort of to really engage and try to pull, what are the key challenges and what are the issues, and what are especially the obstacles to deploy drone-based technologies. And after that, we sort of narrowed down to one is a pilot study, which we assisted another team to conduct data collection, and the second one is a after school drone program that we are conducting right now with one of the high schools, local high schools. So we started the series project in later 2018 for the last 3 years, and phase one mainly about outreach, and phase two is about the online survey, what we learned from the survey summary, and the phase three, which is we are currently conducting, which is the pilot study and pilot program. So with this, I stop here and let's Dan to talk more about the details of the research. Dan, back to you.
Yes, thank you, Jeff. Well, as Jeff said, we had a fairly robust period of initial outreach. I'll be talking a little bit later in a minute or two about the kinds of synergistic projects that have helped to support that, because this grant was relatively small compared to the range of activities we've been doing. And so there's been a lot that we have done to lever those other projects in the interest of this one. The studios that Jeff mentioned were really driven by community priorities for planning, and yet an example of how they help to serve the purposes of this project is in 2018, the first studio that we ran with these workshops involving participatory GIS and a lot of community meetings with local experts as well as members of the public, was focused on how to update the comprehensive plan, which, as Jeff mentioned, is not even mandated for communities of this size and location in Washington state. But this community is quite progressive. That they've invested in that vertical evacuation structure at their school entirely based on their local property taxes before there was any federal program or state program to subsidize that construction. So they've been really at the forefront of thinking about how to live resiliently in the area. In the comprehensive plan, we also took a pretty pioneering position on integrating the hazard mitigation plan at the county level with the local comprehensive plan, and added a whole new sub-element in the transportation element of the plan to encompass, to address telecommunications, and included enabling language for drone use. So that's just one example of how we set the groundwork for the actual drone program we're going to describe in more detail. I'm going to skip over some of these details about how we reached out at a broader area for the survey, but that included National Guard and Washington State Emergency Management Division staff. Go on, Jeff, I think to the next slide. You're going to control this, right? Slide advancement. Thanks. Next slide. Right. So this is findings from the survey. There were 35 respondents, and they were from all the participating coastal jurisdictions and tribes, counties, towns, cities, and tribes that were part of that National Guard meeting, as well as some other contacts that we had on the side. Really learned that it just confirmed that what we pretty much already know about what rural communities need, and that is that you cannot really put a lot of energy and resources and attention and money into very specialized solutions. Anything that you do for emergency use needs to also be useful on a fairly daily and frequent use, and has to train and involve people who have many hats. They have many roles in the community. You cannot have too many people who are very specialized in one knowledge set. So that means we want to actually cultivate from the ground up, at a very young age even, capacity to use the technology in the community for a wide range of purposes. And so that really set the, that was the key message that informed our next step, which was to design a drone program for after school. If you move to the next slide, we just want to acknowledge what some of those other projects are that have helped to fund this aspects of this work and enable us to engage with the community, but also with the hazards modelers and scientists who are providing up-to-date and cutting-edge information about what the actual threats are to the infrastructure and to the lives and livelihoods of the community members. Key to this is the rapid Natural Hazards Engineering Research Reconnaissance Institute based in Civil and Environmental Engineering at the University of Washington, which has an extensive drone capacity, as well as other LiDAR and scanning equipment and technology to integrate those into models, both of pre and post-disaster environments, which we're using from the pre-disaster side to help the community envision what some of the impacts might be of a disaster, and to imagine how that environment might change in anticipation of them. And also to involve and excite more members of the community in that planning process. Okay, if you want to move to the next one. The pilot study that we ended up landing on as an idea with local partners was having students in the school, the very school that has the vertical evacuation structure built within it on its campus, participate in gathering data. we've already done enough data gathering with the drones to model in 3D the entire peninsula of Westport. We have some slides coming up about what kinds of drones we're using. Maybe we could skip to that. And let me see. Actually, you know what? I think we can skip forward too as well. You just get a sense from looking at this. I did want to, Jeff, if you could click on that link, the video. I want to show what some examples of visualization we've been able to create based on the 3D model of the peninsula. And this is something now that tomorrow I will be actually going to Westport. Jeff will be remotely participating via Google Classroom to be at the school to kick off the club, the drone club, with the high school students and with volunteer mentors and coaches from the police, fire, city and public works leaders of the community. Can you click on that and can we show this as a video? Is that not working?
You may have to unshare and share a different
sorry.
screen.
I was thinking I'm sharing this. I'm sorry about that.
Does this video have volume?
No volume.
Okay.
You can
No
see
volume.
that.
Okay.
No volume. Just since the time, then I suggest we quickly show some portion of
How much
this.
more time do we have, Cole?
Maybe 3 minutes.
Yeah, 3 or 4 minutes.
Yeah.
Okay, that's a good enough time. We'll just, so what this is basically, if you stop it at about 1.5 minutes, that'll be fine. What this is a visualization by architecture students, landscape architecture students, and planning students who took our studio you can stop right there, actually, or that's fine too. To visualize what a trail system that is part of that would connect high ground in the community that is safe in the event of a tsunami to parts of the neighborhood that people would need to move along in order to get to that high ground, and how to make it actually not just a specialized once in who knows how many decades or hundreds of years, centuries even event, like a tsunami, which is very rare here, would nevertheless be useful day to day in the city park as a recreational space. So that's the objective behind this. And so we're expecting to be able to excite students in the high school to participate in this kind of work in the future. We can move forward back to the slides if you want for now. To get trained as drone pilots, to use the drones to monitor infrastructure in hard to reach places, bridges and water towers for the Public Works Department, to use the drones to do search and rescue, to play hide and seek, but using them as if people who are in distress in beach in the dunes or in the forests would be able to be found, or people who, or how to run and practice and drill along the evacuation routes and embed those in people's memory and practice. We've had a lot of support from the local community, the mayor, the public works, police. Also, it's important to note that the South Beach Regional Fire Authority stretches, and the Acosta School District stretches outside the city limits. They get into the county, they cross over to the next county, and they include the Shoalwater Bay tribe, an indigenous community that has its students go to this school as well. So we're recruiting their students specifically as well and meeting with them. And they have actually quite an extensive drone and telecommunications facility at the tribe's police offices. So we have this is very broadly embedded within the community. The idea here is that these students will get trained, and they can take in positions in the agencies that do this work, but then they can also use this to get into higher educational opportunities. It's a very low income community. Jeff mentioned it's small, but it's at about 1/4 of the state's average income, household income level. So these students are really need a lot of help to be able to move on into higher education. So I guess this is basically what we're starting to do. We figure it'll be maybe a 7 to 8 week program. It's starting tomorrow. We'll have more to report next time. If you want to move on to, how many more slides do we have here? Maybe too many. So if we skip to the concluding remarks, yeah, there we are. Yeah. That's really what we're trying to do. We're trying to make sure that this is not narrowly conceived, but it has the objectives of this CSET program, but there's a lot of other broader impacts.
Yeah. Thank you, Dan. Yeah, I think with that, we wrap up.
Great.
Yeah. Billy, back to you. Sorry.
Okay. Thank you, Dan and Jeff. As you can see, drones are kind of creeping into everything that we do, and it's important that we plan for that. And it's important that we understand what they can and cannot do, what the laws and regulations are, and what the public acceptance is. All of those are things that are very important for us to understand, and certainly for the smaller communities to be able to avail themselves of that technology. So we're going to change gears a little bit, and I'm going to introduce Sean McKnight. Sean is a professional registered engineer, about 35 years, owns his own company, McKnight and Associates. He works, does a lot of work out in the Nome area for Quartz, very focused on trails and water systems and those kinds of things. And if you want to visit a RIDI community, we certainly, hopefully, once COVID's over, I'm sure Sean will be more than happy to give you a tour of the Nome area. Nome, one of the things I really like about Sean, he challenges me almost on a daily basis to come up with something that I never thought could be done, and somehow or another we managed to make it work. So with that, Sean, I'm going to turn it over to you and let you talk about some of the issues that you're dealing with.
Thank you, Bill. I'm going to try to do this screen share thing, and hopefully I'll get it correct. I think can everyone see that?
Yep, looking good.
Wow. If you don't mind, I'm going to leave that little sidebar up because it helps guide me through the discussion. Once again, as Billy said, I'm Sean McKnight. I'm a professional civil engineer. I work mainly in transportation in the Bering Straits area, which is based out of Nome, Alaska, which if you look at that little map there, it's kind of down the bottom there. We also have several villages out on islands in the Pacific Ocean, one of which is the most remote inhabited village in North America, Little Diomede, Inlet Island. And that literally is about 2 miles away from Russia, because Big Diomede is Russia. Anyway, it's a kind of a remote location. The area that you're looking at is probably the size of half of Minnesota, maybe part of North Dakota. It's a chunk of Alaska. There's about 300 miles of roads in that area. They come out of Nome. You've got a road that goes from Nome to Council. You've got another road that comes out from Nome to Pilgrim Hot Springs, and another one that goes to Teller. All the rest of that is roadless areas. The roads in question that I just mentioned are only operable from about May 1st till October 1st. After that, the Alaska Department of Transportation ceases to maintain the road and the snow takes over. So I was hired as a transportation engineer by a consortium of villages, about 20 villages in this area there, Inupiaq and Siberian Yupik, which you would consider Eskimos. I was a transportation engineer and they've got no roads. So obviously there's a lot of work there. We've had some difficulty in identifying or let me see if I click. We've had some difficulty in expressing to federal officials our trail system and our trail needs. Without roads, we use trails. But generally, when you think of the term trails, you're thinking of a recreational thing. It's do it if you want, so to speak. But out here, these are the only connections between these villages, unless they take an airplane, which is incredibly expensive for these people. And this is a very high unemployment, low income part of America. We've got a concept here for the federal government. We call it Essential Trails and Corridor Program. We're trying to elevate the concept of trails to more of a preliminary or pioneering road. In America, sorry, in the lower 48, a dangerous road, like Wyoming rural road, would have about 1.7 deaths per 100 million miles, 100 million passenger miles. We don't even have that data. We don't know. People die up there constantly. I took a stab at it once, knowing how many people had died on the one such from Nome to Teller, about 70 miles. And the number I came up was between 200 and 400. So what I'm trying to tell you is that traveling from A to B, village to village here, is hundreds of times more dangerous than going from A to B in the lower 48. To make it safer, we're trying to develop a system to mark the trails. Traditionally, they had been marked with tripods, and the slide you're about to see is marking the trail from Pilgrim Hot Springs up to Shishmaref, Alaska, through Serpentine Hot Springs. That was our first big trail marking project. Here we are at, this is the Quartz Creek Airstrip. The little building there is the terminal for Quartz Creek Airstrip. It's actually just a shelter cabin in case you put your plane in there and need some shelter. There we offloaded the tripods. These are pine sticks, 2 inches in diameter, about 10 feet long. We construct tripods on them. We construct them into tripods. We put reflective tape. We load them up into sleds. We can carry about 25 tripods in a sled if we go careful enough. We set them at 300 feet. So a sled load would get us about 1 mile. This has to be done in the winter, and I'll show you what happens. And then we head out across the tundra, and that's what you'd be looking at when you're going across country. Until finally, we get to Serpentine Hot Springs. From that, Quartz Creek to there is about 50 miles. There's Serpentine Hot Springs. It's a kind of historic site. It's really a little, quite interesting place. As the name says, it has a hot springs. It's quite popular. I mean, these folks are all from Shishmaref, and they recreate and bathe in the hot springs. And then we continue now with the trail staking to Shishmaref, and that's what the look would be. This would be in the highlight of the day. That is, when you have the most light of the day. And of course, we're quite far north, so it's often dark. Our primary travel season is about February through April 1st. January and December is often a lacking of snow, and it's just too darn dark and cold. So anyway, that's what you would be seeing. Once we put these tripods up, the intent is to mimic the performance of a delineator on a highway system. And if you've ever been traveling down a highway in conditions that you shouldn't be traveling in, you're going from delineator to delineator to delineator. And when those delineators stop, you get that really sick feeling in your stomach because now you're in trouble. Well, so we want to keep these things up. We put those up. We came back several years later, and this is what we saw. Basically, most of them had fallen over. Understanding we set them up in the winter on the snow, hoping that they would sink down in and hold up, but they just don't. Variety of reasons. Animals will use these things to rub on them, knock them over. What you see here is someone with an ATV got stuck in the tundra, and they used the tripod to get them out. And we don't, that doesn't bother us. As long as they tell us they tore up the tripod, because then we can go fix it. But often they don't. Here's another case where I don't know what tore into that one. I do recall going across on an inspection of a section of trail, and it was in the late spring, and you could see where a bear had come out of its den down the hill, saw the tripods that we had set up during his hibernation, circled it, looked at it, just broke that thing into so many pieces, and then walked off down to the coast. So the tripods had a high mortality rate. The point being, after about 3 years, they're not there unless you maintain them every year. Maintenance on these things is just brutal. The tundra environment is what would be considered, it's considered wetlands. It's extremely difficult to get across, very, very time and energy consuming to do it. We for several years, we tried to maintain all these trail markers, and we just couldn't do it. So we came up with a different idea. One of the tribes had tried to mark the road from Nome about halfway to Teller, and they set C-channel delineator posts, the old delineator posts that were like a C with 2 ears on it, U-channel maybe you call it. They drove it 4 feet in the ground, so it's 4 feet up, and they put a reflector on it just like you would on a road. That didn't work too well because the snow is 4 feet deep, so you really can't see it. And if you hit that thing with a snowmobile, you'll get the idea of what being impaled feels like. It just tore it up. So what we did is I took a chunk of HDPE pipe. I tried to paint it orange. We slapped on some 3M reflective tape and tried it out. We came up with kind of a standard design that looks like this. We're in the process of developing a full-scale test. What you see here is about 1 mile worth of trail marking. So we like that so much, we ordered some HDPE pipe, and we had to devise a way to get the tape to stick onto the pipe. I'm in Minnesota. It's the home of 3M manufacturing, Minnesota manufacturing, which is actually owned by the McKnights, and I'm not one of them, wish I was, but they were nice enough to kind of get me in there, and they performed a series of tests. And from that, we built this machine that we're just starting to test out now that will apply the tape in a manner that 3M recommends, that we hope to get 10 years of life on the tape. They guarantee it for 10 years. And this is the machine we're just starting to use. And once we get these delineators up, we want to see if the public finds them acceptable. If they don't, then we'll try something else. But we're hoping that this will be a device that we can put in and walk away from for 20 years. We'd like 20 years of design life, of service life out of these things. In addition to our marking of the routes, on select locations or at select intervals, we have shelter cabins. This is the Grayling Creek shelter cabin coming from Serpentine Hot Springs heading to Shishmarov. Shelter cabins, as you can imagine, are a real lifesaver if you can get to them. We were working with the National Park Service, the Alaska Department of Transportation, to provide a maintenance program for these shelter cabins. Right now, there's no funding directly for these. For instance, the funding that you would have for a rest stop, that does not apply for shelter cabins because trail systems are not considered highways by the Federal Highway Administration. Each shelter cabin will have has a UHF radio and a stove with fuel oil. So that if you can get in and get a match lit, you should be able to get warm and hopefully communicate to the outside world. They're quite popular. People stop at them all the time. This is the Ear Mountain shelter cabin. One of the issues we've got with them is the bears. If you touch the cabin, if they get the human scent, the bears will eat the wood and tear the thing up. So we've got some maintenance issues. This is Nulik, another shelter cabin. This is kind of an idea of the costs that we have for doing this. As you can see, the cost per stake ranges from $30 to $75 per stake. Mainly it's in transportation, getting to where you're staking and coming across the land that you're trying to stake the project out. The maintenance costs are even higher. coming across in the summer is just a killer. The reason we did it in the summer is the BLM told us that if you really want these things to work, put them up in the winter, come across at maximum thaw, which is about September when the ground is the most thawed, and reset them up and stick them in the mud or the soft earth. Hopefully they'll freeze in. Well, that means you got to traverse this country when it's the most thawed and it's a wetlands, and it's not that much fun. Anyway, that's all I've got. Billy?
Okay, thank you, Sean. It's certainly one of our big challenges up here is marking those trails, and in discussions with some of the folks in Arizona and some of the other Native American tribes, they're having similar problems, but on a different scale of being able to safely traverse some of their lands because roads are not there. They're a different type of trail in many cases, but they're having some of the same issues there. So we're really looking forward to being able to ensure the safety. The newspapers several times a winter have people who either lost or have died on those trails for various reasons. And that also goes for ice roads that we've got a project working on there as well. I'm going to hold the questions and till the end so that we can share the time for questions equally. And so I'm now going to introduce Vinod Vasudevan, who is with the University of Alaska Anchorage, our sister university down in the Anchorage area, sometimes called South Alaska. But he is a professor of civil engineering there. His areas of expertise are in the areas of traffic safety, algorithms, naturalistic driving habits, economics, GIS, and those sorts of things. He's going to talk to us a little bit about a totally different subject, but these are all related in that they are trying to resolve some major issues that our RIDI communities are having. He's going to talk to us a little bit about a project that he's working on to illuminate some of our rural intersections. So Vinod, I'll turn it over to you.
Thank you, Billy. Yeah, so let me share the screen. Okay, so this is the title of my presentation. Developing a prototype of a smart lighting system for isolated rural intersection. As Billy introduced, I am Vinod Vasudevan. I'm a faculty of civil engineering, and I want to recognize my co-PA for this project. It's Dr. Mohammad Kapurchali, and so two of us submitted this proposal, and this was funded by CSET. Yeah, this is a brief overview of the presentation. I'll have a brief introduction, then objective of the study. Then I'll discuss the design concept. As Billy mentioned, this is a different presentation than the previous two ones. Here we will be presenting a product. So we have a design concept, then we'll discuss the components, challenges, the final product that we have as of now, and the future plans. So we all know that rural intersections are extremely unsafe. And not just in Alaska, throughout the US or maybe throughout the world. Based on the recent statistics published by IIHS, 16% crash deaths in rural areas in 2019 occurred at intersection. Actually, this is a reduction from the previous studies. Previous studies showed that roughly 30% of the fatal crashes in rural areas occur at intersections. But more important is, among these fatal crashes, 18% they occur at unsignalized intersection. Again, that's from an older study, which shows that unsignalized intersections are extremely challenging. So they are dangerous because, first of all, drivers don't expect anything there. At the same time, if something happens, getting help there is difficult. Many times, no one would even realize that there's some incident there. So studies have shown that poor lighting plays a major role in crashes, and there are a few studies which mentioned that, which said that if you enhance the lighting at intersections, that enhances the safety up to 33%. So that's something which shows that lighting is important. But looking at rural intersection, lighting all the intersections may be challenging. Especially in Alaska, it's even impossible because we have longer night and access to a power source is almost, impossible to get, especially if you listen to Sean's lecture. That's very similar. In summer or winter, doesn't matter, but the intersections are difficult to access to. So in Alaska, the challenges are most of Alaska is rural and are isolated. Therefore, the challenges that we face is very unique. And most of the rural agencies, so-called agencies, may not even have adequate mechanism to deploy safety interventions. They may not have sufficient manpower, technical know-how, or resources. Hence, if you know that lighting is important, so how can we address that? That's the question that we are trying to address. So we came with this is the objective of our study, to develop a prototype. So we are starting with the prototype, then in later on we want to develop into a product. So this is the first phase. The objective is to develop a prototype of a demand responsive smart lighting system for isolated rural intersection with the following properties. They should be cost effective because we don't want to spend hundreds of thousands of dollars per installation. It should be cost effective. Same time, easy deployment, which means that even people with very low skill set, they should be able to deploy it. And the energy consumption should be low. That's one of the most critical things, because energy is extremely difficult to have. So this is a design concept. Again, it's a very simple concept. What you have is this is for illustration purpose. I have shown a 4-way intersection, but this can be a 3-way intersection or 6-way, 5-way, doesn't matter. So in this case, what we have is we have a sensor and transmitter unit at each approaches. So the concept is that you use the sensor to detect an approaching vehicle. Then using the transmitter unit, you transmit that information. It can be wired or wirelessly, but in this study we used wireless. Then this information is transmitted to the receiving unit. The receiving unit receives it and basically processes it and turns the light on. So the advantage is that it's a demand responsive, which means that it's not on all the time. Hence, energy consumption would be very less. So that's a major advantage. At the same time, several studies have shown that if you have some other system which is there throughout all the time, it won't get same attention. So demand responsive is always useful. So let's discuss some of the components. So it's again, as I said, it's a cost effective. So we had to look at some of the cost effective systems. So we went with some of the most cost effective components that we can get. So sensor and transmitter unit. The sensor we used is Doppler radar. We explored various sensors, but including laser. But Doppler was the most effective at the same time, and under snow condition or low temperature condition, Doppler gave the best result based on literature. And we also tested it. It's true. And what we used is again a particular model. The reason for choosing this was the range was 100 meters, and it was cost effective also. So it gives up to 100 meter range, which means it can detect an object which is up to 100 meters away. Then we have to transmit it. Once you process it, you need to transmit to the receiver. So transmitter, again, these are all extremely low cost components. We use this RF link 435 megahertz thing. This is what it is. Now, then, in order to process it, we used Arduino, so that it detects, as soon as the sensor detects it, based on our criteria, it says that, okay, there's an object, then it gives the instruction for transmitter to transmit the code. Now, at the receiving unit, we use the same RF link 434 because the transmitter receiver, so it will function the same way. So it's the same unit, hence its more efficiency is high. And there also we are using an Arduino to process the data. And as a light, the source should be with minimal switch-on delays. If you notice, most of the LEDs, although they are extremely effective, some of the LEDs have longer switch-on delays up to 2 seconds, which is not something we want because we want to be illuminating as soon as it receives the signal. But since it's a kind of a prototype, we used an LED light, small light, for the prototype. But when we actually do go with the final product, we have to look at the switch-on delays and energy consumption, etc. So, what are the variables that we looked at? So, first of all, where should the sensors be located? So, we all know that the location is dependent on stopping sight distance. So, we have to consider stopping sight distance, which means that if the light is illuminated, then the driver should have sufficient time to safely stop the vehicle. Now, the stopping distance is depending on the speed of approaching vehicles, and we all know how to find the stopping distance based on approaching vehicle. I mean, speed of approaching vehicle. So the speed can be based on the posted speed limit, or better, I mean, you collect some data and see the perceived speed limit, we can use it. It should be in rural intersection. It would be always be higher than the posted speed limit. That's what the literature says. Now, the Doppler sensor also can detect the speed, but that would be after post deployment. So we can't really use this information to locate, to find the location where we need to keep it. So that's the first thing. So we need to determine the location. Second thing is how to define an object. As you know, Alaska has a lot of animals like moose, bear. You don't want to detect them, and whenever the sensor detects, you don't want to turn on the light. So there should be some criteria or some algorithm which says, okay, what is an object? So what we used is we use the speed, because Doppler sensor can detect the speed. We say, okay, if the speed is, again, right now we used as 10 miles per hour. That can be changed because we can change the code and we can change it to any number. So we used, like right now for the experiment, we used as a 10 miles per hour. Also, other thing is we don't want it to detect when a vehicle is leaving the intersection. We want to detect only when it's approaching. So we use speed and direction of movement as a parameter to detect an approaching vehicle, because the approaching vehicle is our interest. Then how long should the light be illuminated? It should be as short as possible. At the same time, it should have sufficient time. If you notice, the time taken for a vehicle to approach an intersection would be few seconds. So that's actually basic necessity. However, maybe that's something we have to decide how long you want to do it. We don't want to make it too short. At the same time, we don't want to make it too long. So that's another decision that we have to make before we move on to the second phase. Maybe 1 minute. Again, that's something we have to decide. So the challenges we faced, I mean, just like most of the projects, we had a lot of issues with the COVID-related restriction because we couldn't use the lab, and that kind of delayed the thing. And also, we couldn't do any long, like actual field deployment. We did some, but it was only a small-scale deployment. Then one of the other issues, the technical issue we faced was the range, because although the manufacturer said that would reach 100 meters, we couldn't initially get. I'll come to that later. So other issue was power source. Again, based on the specification of the sensor, 5-volt battery would be sufficient. So we used a rechargeable 5-volt cell to power it, but it was not working. We faced a lot of issues. So finally, we chose a power bank that resolved the issue, but that took a lot of time because we were trying to make it as compact as possible. Power bank, make it slightly bigger. Having said that, there are advantages in using power bank because that can be easily be recharged. So whenever in the next phase, when we explore some of the renewable sources, power bank would be a better option. So again, these were some of the challenges that we faced, which were not really expected. So the end product, yeah, this is kind of a picture, so this is the sensors. End product range between the transmitter and receiver of over 100 meters, that's what we achieved. And the detection range is, although the detection says it can detect up to 100 meters, but what we found is around 60 meters is when it detects very well, like close to 100%. 100 meters is a stretch. Then the total range of roughly 150 meter, or 530, so it's 160 meter or 524 feet. When you look at the stopping side distance, if you look at Astro Green Book, or you can calculate it, it's 495, which means that if you use the sensor as it is, we can deploy it at intersections up to 55 miles per hour, and which may not be bad, but I think rural intersection we may need to extend the range a little bit, maybe 65 or 70, and can sense traffic from multiple approaches. Although I showed 4 approaches, but it doesn't matter how many sensors you have, as long as the receiver can detect, receiver gets detection signal, it will detect. So you can have multiple number. So we have filed a provisional patent, and we are going for the next stage for this. So what are the future plans? Again, we have this. We are right now working on phase 2. So we are working on phase 2 of this, mainly on commercialization. We have to explore lighting requirement. For example, which light is giving minimal switch on delays, then energy consumption, and illumination. We should have sufficient illumination. Then develop a marketable, ready to deploy product. Enhance the range. As I said, now we are getting up to 525 feet. We may need to extend it up to at least 620. That's the thing. So we need to do it again. One of the option would be to use a different sensor, or maybe a transmitter receiver unit. I think that's something we are currently exploring. The important thing is explore renewable energy sources to power the system. We are looking at various things. Again, solar may not be the best solution for Alaska, especially in winter. So we are looking at wind, especially there are some newer technology in wind, and that's where Mohammed is an expert in. So we are exploring what kind of renewable energy sources we can use. Also, we realized that when we did some field deployment, this system doesn't detect any non-motorized road users. So let's say pedestrian approaches an intersection. Then also we need to warn the motorist in advance, and how we need that. And it's very, I think it's a simple fix. We can do that. That's something we'll be adding in the phase 2. And again, this is what I said. I mean, this currently already detect here, or here. Now we don't have any sensor here. So, but I think that can be fixed easily. Yeah, I'd like to acknowledge, sorry, Mr. Billy Conner. It's a typo. Sorry, Billy. So because he helped immensely, not just in funding, but whenever we had some problem, he helped us and guided us in the right direction. So I acknowledge his support. With that, I end. And any questions? I think in a question, I think Billy will open it up for question.
Okay, thank you, Vinod. If the panelists could turn their video on and their mics on, I'd appreciate it. Do have a couple of questions for you. Sean, the first question goes to you. The question is, are there other technologies, perhaps newer technologies, you think would be helpful in addressing the concerns? And maybe a better way to ask that is, if money were no object, what technologies might you consider?
Excuse me, I was have my camera blocked. We're not big into technology. That sounds kind of odd. I mean, we are and we are not. everyone loves GPS, but if you can't read the terrain and your battery goes out, you're a dead man, period. So map and compass we always carry a map and compass. So if I had my druthers, what I would like to see is those markers in there all the way along. It would be nice if we could possibly illuminate them. That would be interesting. If I had to add technology to that, if we had a way that we could get beacons to people so that when they're leaving, that they can be tracked. And of course, GPS. And like when I go out, I have beacon, GPS, sat phone. I want to call home and get home. I want to go home. So the technologies that I would, if I had the money, we would have the GPS units. We would have tracking units, and we would have sat phones readily available. Because that, with those, you should be able to make it. You have a really good chance. As we make these trails, we GPS the trails, and we publish that, or we're working on publishing that with ADOT. So essentially, you can download all of the trails onto your Garmin, and away you go. But once again, if those things fail to function, you find yourself in a really bad place.
Okay. Thank you, Sean. This one's aimed at you, Vinod. The question is, how have you, or what have you explored the issues related to cold weather and the effectiveness of the sensors that you're working with?
Yeah. Okay. Thank you. So that's a good question. So what we have, and as I said, due to COVID-related issues, we didn't have a chance to explore much in cold weather. However, we looked at the specification of each of the sensors, and they all work in cold weather. I mean, they said, up to minus 40 degrees. That's something that's very good. However, having said that, we also understand that we have to test it. I think I spoke to Billy about it, and he said that there is a kind of a lab where in Fairbanks where we can test it. That's something we'll be exploring in the next phase. But again, having said that, when we tested in Anchorage also, the temperature was still in, like 20 degrees, 10 degrees. So those times it worked, but we don't know whether it'll work in minus 20, minus 30. That's something we had to explore.
Okay. Thank you. And by the way, the cold room is available to you anytime you wish. But
yeah, I know.
Just let me know. Just let me know. We'll take care of you. This one is to Jeff and Dan. If the course with your students goes well, are there other technologies that you can see beneficial to the community and introducing to the community and the students?
Yeah, go ahead.
Sure. Okay. Yeah. Well, we are exploring simultaneously various forms of telecommunications. So radio, supporting ham radio, sort of individual amateur radio operators. But one of the things that we noticed, we have these vertical evacuation structures. More of them are being built. If a big event like that happens, like an earthquake and a tsunami, they will be very isolated and very small areas, and cell systems will be down. Some of the problems that Sean mentioned would apply on our coast in the lower 48 too. How much drones or any other tech could build sort of local capacity to broadcast, as well as to communicate outside the area using lower tech, as amateur radios, ham radios are much older, but making that relevant to everyday life which is a social media world now. So young people, especially that we're trying to involve in this, can see this as being relevant to their Facebook and Instagram activity, how you can stream low power FM. I'm really interested in community radio, and in Washington State, actually, it was one of our senators, Maria Cantwell and John McCain, who in a bipartisan fashion crafted a community radio act that is national now, that really supports a certain amount of bandwidth going to nonprofit local low power FM, which can reach a community at the scale of, maybe 3 or 5 miles without a lot of interruption. It's completely overwhelmed by commercial practice, but if there can be ways of supporting communities to make use of this tech, it does build resilience. So that's the first thing that comes to my mind.
Okay.
Jeff?
Yeah, I think that's all. I don't have further.
Okay, thank you. Vinod, all right, well, I'd like to ask Sean a question that goes along with that as well. Are there educational materials or courses that we might bring to the villages to help them increase the safety of traversing some of these trails, such as introducing some of the new technologies that may be available, helping them improve their map skills, if you will? Would those types of courses within the high school or to the community as a whole be helpful?
Traditionally, they have courses, so to speak. In every village, there's going to be travelers, a group, generally men, not trying to be gender biased, but they're generally men. Travelers, they also usually the hunters. And these are the guys that can go anywhere at any time under any condition. It just doesn't matter. These men usually mentor others, or used to mentor others in this process. The problem that we are seeing is that interests are changing. So the young people aren't so interested in going out in the country. They're interested in computer games and things of that nature. So they don't get that. They don't get those skill sets embedded into them. So they just don't have them. It wouldn't be a bad idea. This is a rare one. It would not be a bad idea to have a winter survival course taught by the locals, just to remind them that, hey, when you go traversing out there, you're in really big trouble. One of the interesting things I do is, as far as driver safety, there's no vehicles. So when I build a road in a village, especially if I pave the road in a village, all the kids come out and play on the road. They don't know to get out of the way of a trucks. They don't know they just don't know what to do in the road. They just kind of stand there because it's a road. And in fact, as odd as this is, the village of Einlich on Little Diomede, it's very isolated. They don't have any vehicle, maybe one snowmobile. You walk, you take a boat. When those folks come to Nome, the children, it's like having puppies on the farm. They have not a concept of what a vehicle will do to them if it hits them. They just don't get it. So there is survival training would not hurt at all. Just to remind everybody that it is pretty dangerous out there when you go. Okay. But again, they try to hammer that in through their culture.
Okay. Another question that we have, are there other areas such as the U.S. Midwest, Canada, or Europe that are also looking into some of these issues? And these, indicated that these problems are perhaps more common than we city folks realize. So any comments from the group on that?
I just add one. I think short answer maybe yes, but I think every community is different. You will have to look at the specific issues and the culture there in order to develop solutions that fit and effective for that particular community. And for some communities, as folks here mentioned, training is important. Drones that's why we set up this program in order to train the talents and experts in the community.
And also, Jeff, I agree with Jeff completely, but I would like to add that the problem that we are facing, especially in Alaska, rural Alaska, similar experience, I think you wouldn't find in North America, but predominantly be applicable in Asia, Africa, etc., because they also have huge energy crisis and it will be difficult to power it. So if we can have some kind of a renewable source which can illuminate intersection, that would be good. When I spoke to someone in World Bank, they said, if you have such a product, they would be also interested in exploring again.
Yeah, it's also been my experience throughout the South portion of the U.S. There's a lot of back roads, if you will, and they have no lighting, no delineation, very few signs that your technology, Vinod, could apply to. And Cole, you had a comment that you would like to add in here?
Sorry, yeah, I guess I would just say, you know, we're approaching the end here, but we do have a few more minutes. If anyone else in the audience has a question for one of our panelists, please put those in the Q&A box. Once we've kind of run through the questions, it'll be time to conclude. So if you have a question, ask it now.
Okay, thank you, Cole. The other question is for Dan and Jeff. Do you have any students need a? Sean's asking this. Maybe you can catch up with him offline, but he's looking for some students to help him out in the summertime, especially with LiDAR and high-res drone experience.
I'm looking for a drone pilot that can fly a drone, large quad, collect the data in a preformed pattern, can download the data, make sure he's got what he's got, and then he can ship that off to our engineers and they can process it. But we work in Alaska. I had a guy, really good guy, really loved it. And then I brought him to Alaska, and no, it does get dark at night, and yeah, you're not on the top of the food chain, and no, there's no bathroom here. And you're 100 miles to the nearest light bulb. He lasted like 2 weeks. He's out of here. So, I mean, if you've got a guy that can actually do that, I'd love to talk to him.
Yeah.
I think I gotta go. I have another 12-minute I'm late for, but you should definitely. We have the Neri Rapid facility right here, and I think that's a huge resource for needs like that one. So I'll let Jeff handle that a little bit. It's really great to meet everybody. Thanks so much. Bye.
Yeah, thank you, Dan.
Thank you.
A quick follow-up is that, yeah, we do have a rapid facility on UW that has real expertise on this subject, and also we have graduate students who have the drone pilot license who can operate those things. And the high school students, we have about 15 to 20-ish. Hopefully through this training program, some of them will get a license and they can operate drones. I'd be happy to talk more offline to see if we can.
Thank you, Jeff.
Thank you. Well, I certainly thank all of our panelists for some very interesting topics discussed. As I say, they're very different, but yet they're all addressing similar kinds of issues in the end, and it certainly brings it to the forefront. Those of you who are still with us, thank you for joining us this afternoon. Certainly, if you have any additional questions for us, I'm sure that if you contact any one of us, we'll be more than happy to answer your questions or help you out in any way we can. So with that, Cole, I'm going to turn it back over to you to close it out. And all of you have a very pleasant day and a great weekend.
Yeah, thanks, Billy. I guess the last thing I will say is this session was recorded and it will be posted to the PacTransConference.com website by the end of the day today, along with the rest of the conference activities. So if you have things you heard here that were interesting that you'd like to share with others, it will be recorded. And if you need a slide deck from someone, you can email us at pactrans@uw.edu, and I can put you in contact with the presenter and you can talk about sharing that with them. So yeah, I'd like to echo my thanks to all of the presenters as well as the attendees today. This was great. And I think with that, we can conclude. So have a great day, everybody.
Bye, Billy. Thank you, gentlemen.
Bye.
Thank you.